Welcome to Study Loop.
In general, what we're going to use for parts B and part C is the fact that the Max-Born normalization condition for this cubical volume of a box is equal to the integral over dx dy dz of the wave function psi squared is equal to 1, where the wave function psi is equal to some constant c, right, times sine, and I'm using the notation this s here is equal to sine. So this is the sine of what's ever in the parentheses. So sine of nx pi x over L, sine of n sub y pi y over L, and then sine of n sub z pi z over L for the stationary state wave function of the particle inside the cubical box, where nx, ny, nz are just some integer value, and c is just a normalization constant. For part A, though, to find the fractional volume, we're given the fact that the cubical volume is defined by the parameters of x being between 0 and L over 4, y being between 0 and L over 4, and z being between 0 and L over 4. So the volume of the cube is v, and it's equal to L over 4 cubed, right, for x, y, z. Well, the total volume of the box, v prime, is equal to L cubed. So the fractional of the total volume of the box in this cubical volume is equal to v divided by v prime. So we plug in the values for v and v prime. Of course, the L values cancel because we have L over to the third divided by L to the third equal to 1 over 64. You get it as a numeric, like as a decimal value or as a fraction. I'm going to leave it as a fraction value. For part B, this is when the probability function and the wave function come in, because we're going to find the particle in the ground state, which is when ny, nx, and nz are all equal to 1. To calculate that probability found in the cubical volume defined, so in part A. So this is the x, y, and z defined being between 0 and L over 4. So those are the numerical bounds of our integration. Okay. So let's get into it. So what we have here is, let's go ahead and pull the constant out front. So what we have is c squared. So we're just plugging that value of psi in for our probability equation. So c squared, we have integrals from 0 to 4, right? For everyone, for x, y, and z. L over 4. And then you have all the functions now squared. Sine squared of x pi x over sine squared and y pi y over L. And the same thing, sine squared n sub z by z over L. Okay. And then you'd write the n L. We won't write that. That's what would go there. And then the volume, of course, is dx dy dz is equal to 1. Equal to 1. Okay. So what we have here is c, the constant squared. And each one of these comes out to be L over 2. L over 2. integrating sine squared nx pi x over L with respect to dx from 0 to L over 4 gives you L over 2, L over 2, and L over 2. All equal. So we find that from that, C is equal to 2 over L to the 3 halves. Okay, so now we know that, we can plug that in. We can plug that back in, and we find that this integral is equal to, using a table, we have over 8 minus L over 4 n sub x times pi 9 of n sub x pi x over L. So this is just for the n value. So it would be the same for y and n sub because they're over the same value. Okay. So from 0 to L over 4, so this becomes 2 divided by L to the third times L over 8 minus L over 4 to the third. So this is equal to times L to the third, L to the third, times 1 minus 1 over 4 pi. And finally, L to the third, we are left with the value of 7.49 times the minus 4. Okay. And now the probability for nx equal to 2, ny equal to 1, and z equal to 1. Again, we have so we have the probability is equal c squared between 0 and L over, and this is all of the integrals, right? Over 4 for all the of sine squared. You have nx pi x over L, ny pi over L, and z over L for every single one. Okay. So I'll do for one and then to painstakingly single writing. It's the same thing for both of these, right? So this is x over n, and then sine squared y over L or over L. So y over L, z over L version, dx, dy, dz. Okay, so now carrying out the integral, we get the exact same thing for nx, ny, and nz, right? So you have replacing the c with what we were given before. So we have 2 over a third times over 8 over 4 x pi times the sine n sub x pi over 2 n sub x and n sub z are equal to 2, 1, 1 accordingly. And then just again, it's the same thing now for you multiply this by thing for the y, except replacing everything with y, the n sub y instead of n sub x. And then for the z, it's the same thing. It's just okay. And then carrying this out, we find that this is equal to 2 L to the third times L8. That's common in all of them. Pull that out. We have 8 minus L over 4. This value. We notice the L's cancel, and this comes out to equal 261. Times 10 to the minus 3. We can box set the solution to our question for part C.